Okay. Firstly, let me introduce us. We're a very small startup, and we mostly do two things. The first one is we develop Tempest FW. It's a hybrid of HTTP accelerator and firewall. It's just do a lot of good things in one piece of software, like web acceleration, DDoS mitigation, HTTP load balancing, and a lot of stuff with HTTP. It's very fast. I believe this is the fastest open source implementation which you can find. We beat any modern user space web accelerators and load balancer for several times, and we can ever beat kernel bypass technologies. The reason for so high performance is our Linux kernel TCP extension of TCP IP stack by HTTPS. This Saturday I had a talk at Linux NetDev conference, and you can find the description of the project at this link. I think the paper describing the technology will be uploaded soon. And we also do custom software development and consultancy in various areas, mostly in high-performance computing, in low-level development. For example, we made a web application firewall, which was mentioned by Gartner in Magic Quadrant as a visionary. So AsOf feature is based on SQL standard. And the main thing about the feature is to be able to store all history of all rows in the database. The primary application for the feature could be point-in-time recovery, some legal issues like if you have requirements to store your data for several years and so on. And also very interesting thing is that you can run data analysis queries like to see what was in previous year, which deals you made, how they change, and so on. Let's assume that we have a table with only one row, and we execute update of the row. Basically, we just mark the row as invalid and insert the new row. If we delete the row, then we just mark as deleted. So physically, now we have two rows in our table. However, if we run select, then we will see expectable results. There are no records in the table. Meantime, if we want to get history slice, we can do this. In this example, we have the same table, but the row just updated many times. So at the end, we have only one live record version and a lot of dead rows. If we want to run AsOf query at the point of timestamp 0, then we will see only row with value 2, because at this point in time we saw only one version of the row. Also, we can do range queries. The range query show you all the version between the 2 points of time. So at this time we saw 2. At this time we also saw 3. So all the two versions are joined, and we see two resulting rows. Recently, MariaDB introduced a flashback feature, which is based on binlog extension, and this very close functionality to AsOf. However, the feature have pros and cons. While it's based on binlog, it's typically limited in time duration when you can do the queries and the recovery It can be very slow to load to large history and flashback the history to original state. What the feature does, it's just replay binlog with inverted queries. For example, if binlog has insert statement, it's converted to delete. If it has updates, then update versions of row are inverted. In AsOf feature, the main point of the feature is that we have strong queries, so we can do very powerful selects over historical data. And basically, we are limited to only 2 database engines. I will explain why we need the limitation next slides. And one of our main targets was to be able to survive DDLs. So if you at this point let we have alter table, and this one version of table with one scheme, and this is the other one. So in this with AsOf, we must be able to run between statement over the alter table. So different schemes of tables will be able to join it. Just for quick start, let's consider a couple of examples. The first thing is that we introduce the new syntax extension for create table. We specify that we use system versioning. Next, we insert values just like to normal tables. Now we define some timestamp, and let's do the second insertion. We type the command manually, very slowly, so all of them have different timestamps. And now we can make a AsOf query. We're interested in point of time at this place, so basically we saw only one line in row in the table. So this is what we see, just one row. The next point is between statement. We basically do the same. The first query we do insert. Now at this point we see the row with value 1. At point 2 we see the previous row and its modification. Delete is seen by point of TS2. So we have we see 2 versions of rows. And now let's pay attention to the new columns in table. I will explain them a bit later. Now we interested in the values in the columns. The first value is transaction ID when the row was created. The second value is transaction ID when the row was deleted or deactivated. Since we do update at just before second timestamp, the same transaction deleted the first row and inserted the second. So basically now we see that update is just 2 operations, insert and deletion. At this point, we might think that we basically can do the same things using plain SQL. For example, we can say that instead of inserts, we can just introduce one more column which will store date created when the row was created. Instead of deletion, we just add another one column and just put mark that the row is dead. Updates are a bit tricky. They require some trigger to be able to replace update statement by insertion and deletion. And select just introduces additional where clause which runs over the timestamps. Basically, the approach is described in this article. The article introduces much more columns and much more complex things, but basic idea is this one. The problem with the approach is that basically it's very complex. When you need to do some complex things with your database, you must write very complex triggers to handle the semantics of the historical data. It's also slow because each query must run several statements. It can live only with timestamps because at SQL layer we do not know about transactions. And typically you either must to modify your application layer or keep the SQL statements in your database. However, main target of history databases are to be transparent for users. And basically there are several implementations on the market. It's Oracle, IBM DB2, Microsoft SQL Server. I'm not sure about MySQL SQL Server. It uses a bit different approach from the first tools. Oracle basically do very simple things. It uses undo log for historical data. In undo log, we have all history records already, and we can reuse it to make point-in-time recovery, make some queries, and so on. However, since undo log is organized in linked list, it's slow, and it isn't scalable. Also, Oracle do not survive altered tables, and probably the same things with MySQL. I'm not sure. So the goals for MariaDB AsOf, the first one is that we must be able to survive altered tables. The second one is that we must concentrate on InnoDB as the most widespread engine. And basically, we try to do as much as possible at SQL layer without interaction into InnoDB layer. So this way, we can extend the feature to other storage engines easily. Basically, now we have MySum logic. We didn't touch MySum code at all. So history queries on MySum just use SQL layer. The feature is transparent for at application layer. You don't need to do anything at application layer, but database administrator can run the history queries, and everything works out of the box. We use standard for our syntax extensions. However, not all the statements are defined by standard. For example, removing history is not defined by standard, so we introduced our own syntax. And the typical use case for the feature is to be running at a synchronous slave. The motivation for that is that when you write history in OTP database, we have a lot of updates, and history grows very quickly. So it's a good choice to put it to a synchronous slave and let it to get the history. This basic statement about the new columns. This InnoDB output. So for InnoDB, we store the columns in as integers to store transaction IDs. And interesting thing is that one of columns automatically added to primary key to be able to quickly run queries on historical data. Also, we have implemented hidden columns. It's very very limited implementation, not what MariaDB is working on its feature, and it will be merged with MariaDB feature when it will be ready. Yeah?
How can you add a nullable column to the primary key?
Pardon?
How can you add a nullable column to the primary key?
Hidden column?
Nullable.
This not nullable.
Yeah, the ending timestamp if the row is not deleted is nullable.
This not nullable. This to primary key we have a not nullable key, primary key. Yeah, see. Yeah.
What do you store there? They just some arbitrary large timestamp?
We don't allow you to insert.
No,
No.
I mean, if the row is not deleted yet, what do you have in this column?
Pardon, I didn't get the.
I guess you could store 0 there because
We didn't store. When you define your.
Yeah, I mean, if the row is not deleted.
And we add versioning property to the table, right?
Yeah, so from the table there is version, and you insert a row, and row is not deleted. What do you
Yeah, I believe we'll set 0 to existing rows when we add history property to the table.
row has 0 for the
I think, yeah, yes.
Actually, Alexander, if you go back to that one, the SQL standard, they make both start and as part of the primary key.
Pardon?
Both of them is part of the primary.
No, SQL standard does not say about adding them to the primary key. Standard doesn't care about it. It's implementation detail.
Okay.
It's an implementation detail, absolutely, but they elected in IBM's implementation to both of them as the primary key. Because including one of them may create trouble. Yeah.
Okay. So this my sum table. For my sum, we have no access to transactions. We fully work at SQL ways, so we use timestamps for the columns, and also the column added to primary key.
Do you support full standard syntax with periods and all this stuff?
Pardon?
Do you support the full standard syntax with periods and all this stuff?
Yes, I will talk a bit about it a bit later. And yeah.
Oh, yeah.
Yeah, this is the time with yeah. So, do you have Jens?
Yeah, 2 slides before, you added the notion of a transaction ID. This is the MariaDB transaction ID?
Yes, exactly. This is MariaDB transaction ID. The interesting thing which I will say about the MariaDB transaction IDs. This create table, you can use the syntax. However, we basically you can specify any column names which you want. However, we support only one column for row start, one column for row end. You cannot add arbitrary columns with to specify row start and row end, and you must use the column names for periods. So from our point of view, this is very verbal syntax, and basically we do these things by default, and there are no other way to make the things.
But it's not your limitation, it's a standard limitation.
Yeah. Why we basically it's why we had to modify MariaDB for the feature, and why we're not happy with timestamps. Basically, one of consideration of AsOf features is to be able to provide transactional view to some point of time. So we have to provide view of database states just like MVCC sees it. The next point is that when we run in multiprocessor operating system, there are no guarantees that two processors calling system time will see monotonically increasing time. For example, the first processor can get the time first, second can get the time second. However, the second processor can see time less than the first one. So operating system doesn't guarantee monotonically increasing time in multi-core and multi-CPU environments. Also, timestamps are true codes, and basically transactions can have the same timestamps. So to resolve the issues, we use transaction IDs as unique identifications. To convert timestamps to transactions, we use additional information schema table. The table also introduces commit ID. So we have transaction ID when transaction starts and commit ID. At this point, we modified InnoDB a little bit. This transaction ID, which is native for InnoDB. However, we use, so when a new transaction starts, we do atomic increment of the counter. And when transaction commits, we do one more atomic increment of the transaction ID. So each transaction essentially increment transaction ID for 2 instead of 1 as previously. And this thing allows us to be able to resolve MVC view to see which transactions were seen at particular for other transaction. I will describe the algorithm a bit more. And for the transaction view, we introduce additional column. It's isolation level. And while we typically have 4 isolation layers, we end up with only 2 of them because say that's just a definition. For repeatable read, we do the same things for repeatable read and serializable, and the same thing for read committed and read uncommitted things. This algorithm, how do we determine that transaction 1 sees transaction 0? The first one, if transaction 1 started after the commit time of transaction 0, then obviously transaction 1 sees the result of transaction 0. However, if transaction 1 committed after transaction 0, and we know that in this case we have a intersection of transactions, and we verify ISO level. So if it's read committed, so we see committed transaction before current transaction committed, and we return true. Okay. Yeah.
This doesn't seem to match the MVCC definition inside InnoDB.
Maybe so. This is our concern. It seems we didn't broke anything in MVCC view. However, it seems that for AsOf we still can get the right view in InnoDB. It's not the real MVCC, but it still allows to see the view of database.
I think that in InnoDB, we have those both intervals, and then we also have a list of transactions.
This is the thing which we started from. So initially, our table contained concurrent transactions instead of commit ID. So we maintained a list of concurrent transactions which took place when current transaction with transaction ID begins. It's the real MVCC, right? So it's a bit bit complex to handle the real list of transactions, and basically we do not see any problems with current scheme. It seems that we do not run real transactions. We do not resolve any locks and so on. We just care about database view at particular time. So it seems we didn't block the view.
I will have to create some test cases to see if that really
Yeah. We did testing, and basically we didn't find. And probably this is point for discussion and code review to verify the statements. However, we didn't find any problems with getting the view in such scheme.
I will be doing the NLP code review, that's why.
Yeah, I know. Since we have a lot of data, this trivial case for data partitioning, we use MariaDB native partitioning to store the history data. This is how do we specify the partitioning in create table. The first partitions store history data. In this time, in this case, the first partition will store the first month. Second partition will store the second month, and the last partition always contain current versions of data. So if you do partitioning, you must specify the last record with AsOf now. We are able to do partitioning by limiting number of stored records or by period of time. We also use partition pruning, means that when you run your query, you can determine earlier which partition have required minimum and maximum values in transaction IDs, and we choose only required partitioning to satisfy the query. To be able to do such things, basically we modify select statement at very early phase before optimization. So when we add additional where clause to select, we pass the clause to optimizer. So basically this is the same thing which point-in-time architecture does. We just store current data with sys transaction and infinite. Infinite means the maximum integer value. And table is used to convert the time to transactions. Basically, VTQ table grows very quickly because every transaction updates the table, and all the tables move data into the table. So practically, it has sense to run some joins over current investigated table and VTQ table to see data about which transaction modified the record at which time, which commit ID it has. And now we see the large transaction ID, this maximum integer, which specifies that the record is still alive. So if you see some small number in transaction IDs, typically the record is already dead, and large integers means that the record is still alive. Insert also trivial, just like in point-in-time architecture. We just do this at the scale layer and in DB, so it's transparent for application. Delete also very trivial. The one important limiting is that you cannot delete historical records. So you can delete only current records. However, if you want to delete some historical data, you're not able to do this. This is done to satisfy security requirements for our edition. Update is the tricky part. Basically, it's also insert plus delete. We copy a record, insert it to database in original state, set the transaction IDs, and that's all. History purging. If you need to remove some old history, you must use truncate statement. This is not a standard definition. Basically, standard doesn't define the syntax. And we can do truncation of all the history and before the timestamp. Yeah, this one.
No, previous.
Mm-hmm.
So you say it's an insert plus a delete.
That's wrong. So it's technically it's update. So we update system transaction end of current record to set it to current transaction ID, and we insert the new record, which is essentially a copy of the old record and with the right IDs.
So it's an update and
Yeah, and insert. Yeah, sure.
so this is in the non-partition
Pardon?
use case. Right? Because you said that there's two functions. There's the partition
Mm-hmm.
situation where you put your history in with the partition.
Mm-hmm.
There's the other use case where you put the data in the same partition. Right? So I think the update would behave differently in one or the other.
Sorry, I didn't get.
Too complicated for a line.
There is a partition, it would be better to update the record in place and to insert the old version with the other partition.
In the partition use case, there will be an insert in the partition and you update the
Because
record.
you can do that in both cases. Just both in both cases.
Yeah.
Insert the old version and update the current.
Yes. Okay.
Okay. The one extension of the feature is that basically you might not want to store all the history, but rather if you have some column like Y in this case, which updates frequently, they are not important for you, but you want to store history only for the first column. So we can do this. You must specify system versioning only for one column. You can do this by alter table if you need to adjust existing table without history. You also can do this at create table statement. And the interesting thing is that when we do history queries against the table with only one system versioned column, then you see nodes in all the columns which are not tracked by the history. Basically, if we do not interested in history of a column, we don't. We have a lot of records. For example, we have a record which has x33. And if we update Y in this record, there could be a lot of updates which we do not track. So we do not know which value we should contain in the history record which corresponds to a particular X value. So we just chosen to set nulls for untracked history, for columns which are untracked by history. And don't care about values for unchecked columns. Okay. So the range queries. Basically, we can do range queries for timestamps. This between statement, it includes the first time and the last time. So all the records seen in particular point in time are included into the query, into the query result. This is different from two statements. So basically, we see different values for them. Basically, this requirement of the standards that we must implement between as well as from to. And it seems that between could be useful to get the database state for time frame, particular including all the records, while to from is useful to get the state just before a particular time without inclusion of data seen at the particular time. So in this example, we see that if we set the second transaction for query to from, we exclude the records with the transaction from the result. This range queries for my sum. Basically, we can do the same as for MariaDB, but since we have no transactions, we return error code if we try to make query on transaction. Foreign keys. If we have a record in one table referencing to second table, and now we delete the record from the child table, which has a foreign key constraint. Basically, at this point, the record is in history. However, it still exists physically. However, in normal point of view, or normal database point of view, the row is dead, so there is no constraint on parent table, and we can successfully delete the records from parent table. So it means that if you have historical records in your database with foreign key constraints, the constraints are not verified against history records. Okay.
And how do you do that? You automatically add transaction end to the foreign key?
We made if statements at foreign key validation constraint. So we almost finished this roadmap for our further development. We are already working in DDL survival, so MariaDB 10.3 will have persistent history. That means that when you do alter tables, you will store all the tables. However, to query the tables, you must specify their names explicitly. Audit plugin is required to know transaction ID from log file. We also probably need special privileges to make truncation. Maybe other storage engines also will be considered. And I want to say more about DDL survival. This is basically a topic to be discussed. We have a wiki with a description of current proposal about DDL. The first thing which we need to survive alter tables, we need to add a new table. The table contains transaction IDs for table credentials and altering names of the table, which which names the table have before and after modification. And since there could be a lot of altered tables in particular installations, we store table descriptions in the table to be able to run the queries faster. We propose multi-schema selects, like if you have no, if you have a table representation with a new column and without the column, we can put nulls if we join the query and so on. Then also interesting topic to discuss is in place DDLs. For example, if we rename a column, basically there's no sense to copy the table to different file just to be able to run the query. Probably we can extend the table or create another table which will just track in place DDLs to avoid additional copies. Okay. Marco?
Yes, yeah, that sounds reasonable. I mean, I have some plans about transactional metadata storage. I hope that this would be somehow merged with that idea.
Mm-hmm.
The same thing would be in the future. Basically keep all the table definitions in a transactional table and use the Ethereum files only for some special purpose.
Yeah, maybe we can discuss the design and develop it further. Because now we're starting to work on the feature, and if we can adjust the design, it will be good to know now what we can do.
Yes, I would like to discuss.
Okay. So yeah, cool. So that's all. I want to thank our team, Alexey Medenkov and Evgeny Kotsov, who works on the project, writes the code, and make the code live. The source code is available at GitHub. This is MariaDB 10.2. However, we merged it to some old version of 10.3. This is our blog. We sometimes post some performance research in the blog about high-performance computing. And this is source code of our own product, Tempesta FW. So thank you. Any more questions? Yeah, thank you.